Hello and once again welcome back to this new video where we are going to discuss a very not important but extremely interesting topic, that is electromagnetic induction. Fine. So what exactly the meaning of this flying you can say unmanned aerial vehicle, or this is known as drone, normally used by various YouTubers to record their videos or security agencies to take care of the specific geographical area. So we'll discuss what exactly the relation between electromagnetic induction and in this you can say drone. So this is first video. We'll keep on creating videos in this series to explain this electromagnetic induction with lot of practical examples, because this concept is very important for even the generation of the uh, current electricity. So why study physics? There is no need to study the physics. Physics is very interesting uh, concept or topic, so you just have to enjoy the physics because it is nothing but the study of laws of nature. So here once again welcome back to the Bye Books channel. So let's move ahead. This is the basic idea of electromagnetic induction, and it is important from the academics point of view. So here I mentioned the definition as it is mentioned in various books. Important aspect is generation of an electromotive force across a coil or conductor when it exposed to a changing magnetic field. Now this fundamental principle in physics was discovered by Michael Faraday. It was year 1831. So you can say from current time it was around 193 years back because it is 2024. So roughly 200 years old phenomena, but very useful and important. So this is the basic principle of electromagnetic induction. Here I mentioned the Faraday's law that somehow I also explained in the starting. Induced electromotive force is proportional to the rate of change of magnetic flux. Magnetic flux concept that is associated with the you can say phi. We already discussed in the previous video. Phi is equal to BA, where A is the area of the coil, B is magnetic field, and so on. Then another aspect is the Lenz's law. Fine. So direction of induced current is such that it opposes the change in magnetic flux. Here one very you can say interesting example I placed in form of a video. This is a band, health band or wristwatch used by the people to monitor their health in terms of like number of steps covered, you can say taking phone calls or heartbeat. So all these things are uh, monitored by this device. The charging is based upon the electromagnetic induction phenomena because there is no direct wire is connected to the device. In fact, our pad is connected with the wires and there is a contact between the watch and the pad. How exactly it is taking place? In the same video we are going to elaborate. This is the explanation. Actually, here the wire is not directly connected with the device, but the wire is connected to another device known as the electric pad, and then this mobile phone or wristwatch is placed onto that phone. And what exactly is going on here? Building charging coil inside the wireless charging pad generates electromagnetic field, and this field sends energy through inductive coupling to the induction coil, and then battery of device is charged using this transferred energy. So this is a very interesting you can say application of electromagnetic induction. Then from the academic point of view, we mentioned these two laws associated with the electromagnetic induction, both laws given by Michael Faraday. It was year 1831 itself. So first law says that mathematically we are going to take care, because this statement we directly picked from various books like that. So it is EMF, induced electromotive force, that is EMF is given by minus d phi by dt. Rate of change of flux already we discussed in previous videos. Here my question is, if you have observed those videos, just try to answer the meaning of this minus sign. All terms are explained over here. So in comments you can mention your answer. Then another is your second law, that is Michael Faraday's second law of electromagnetic induction. So mathematically somehow this law is similar to previous one, that is EMF is equal to minus n d phi by dt, where n is number of turns. Again, what exactly the meaning of this minus sign, try to mention it in the comments. So these are the important aspects from the academics point of view. Now here I explained this Faraday's experiment. Very properly we tried to mention the direction of the current with the help of the galvanometer and the motion of the magnet. So just take a look. When the magnet is moving away, the direction and this changing polarity mentioned over here. Now, when the magnet is moving away, it is going to be south pole. It tries to hold the magnet back. And when the magnet is going towards the coil, it changes into north pole, it opposes the motion. And accordingly, the direction of the current is also changing. So these 4 points we mentioned over here. So this is Faraday's experiment, and here we explain the observations, explanation and direction of current. This is nothing but in short explanation of the Faraday's experiment. These 2 points we already examined in the previous slide. It is the explanation, and here important aspect is direction of the current. So by just taking the look or reading it, you can easily understand, because I explained these things in the like previous slide itself. Now, key factors influencing the induced current. So first is strength of magnetic field, because stronger magnetic field will induce a larger current. I expect the answer of this why in comments. Fine. So in comments, if you are observing this video, just try to answer. And again, the second, rate of change of magnetic field, as faster charging magnetic field will induce a large current. So try to answer it also. Then area of conductor. As large conductor area will intercept more magnetic flux. So larger current. Here again, I use a drone, 3 rotor blade. So how exactly these drones are associated with electromagnetic induction? Next slide we are going to explain that. Now, this again a type of drone you can say, and these are the you can say direction of the magnetic field lines. Here it is the explanation. This is the drone, and these are the induced dipole moment, induced flux. So basically these type of devices are used to block the or jam the mobile networks. It's one basic you can say interesting application of the electromagnetic induction phenomena. So that's why I use these drones, normally used by YouTubers to record the videos, or security agencies to examine or taking care of large geographical area, something like that. Then Lenz law, as I said, Lenz law is important. So this Lenz law, direction of induced electromotive force, and it is the consequence of the conservation of energy. Fine. And it is very closely associated with Faraday's law of electromagnetic induction. These two small flying aeroplanes, the question can come in your mind, is there any type of electromagnetic induction phenomena associated with this? Answer is up to some extent yes. We'll elaborate in coming videos. Then application one by one. In coming videos, we will try to elaborate it. Here we are just mentioning what exactly some applications, not exactly all these. Metal detectors used by security personnel to check the presence of unwanted metals and all these things. Microphones, say for example, with the help of which I am recording the video. And in the next video, we will try to pick up these topics. This is, you can say, a plan for the next video. A very beautiful application of ED currents is in maglev trains to use as a brake. So here would like to say thanks. These are what? These are windmills. Fine. And windmills are used to produce the electricity, that is with the help of air. So here the pure application of electromagnetic induction is used. This is cross sectional area Over here, these are jet streams anyway not associated with electromagnetic induction. It is just for the interesting aspect. So I'd like to say thanks to all of you for watching this video. Keep coming and watching the video on the channel Bye Bye Books, and try to mention your comments and answers. Once again, thanks.